Hello students, welcome back. Let us discuss one example of finite state machine in this video. So we are going to talk about how to construct one finite state machine for a given problem statement. So the problem statement that we have is there is an infinite stream of letters A and B. These are randomly placed and they are infinite in number. It's an ongoing stream. We have to identify the letter A. Our focus is on letter A. If the number of A's till the given time from the start is odd number, then the output will be 1. Otherwise, it will be 0. So, what are we going to do? There is a stream of A's and B's, infinite stream. Let us say at one time the number of A's and B's is 1000. Out of them, number of A's is 555. That means it is an odd number. At that moment the output will be 1. And at any other moment, if I count the number of A's and it turns out to be even, then the output will be 0. So this is the statement that we have for our system design. So how do we solve it? The stream length is infinite. So we are going to have infinite states or not? Well, if it is a finite state machine, we cannot have infinite states. At one given time also, the number of states can be large. As I said, number of A's can be thousands or even millions. And it will be practically very difficult to have millions of states in our finite state machine. So we should think of something that can help us in solving this problem with minimal number of states. So we said, okay, let us look at the logic. We are not asked to tell the number, that whether the number is 555 or 2020 or 1,003,025. We are not asked to count those. We are simply asked to detect if the number is odd or not. Okay, we are not asked to get the count, but only to check whether it is odd or even. So we will define only two states, and that will be whether the number of A's are even or odd. With these two states, we will try to solve this problem. So let us see if this will be feasible to solve this problem using only these two states. So we start the construction. We said I have my state which is odd, that means number of A's are odd, and /1 means whenever I am in this state the output is 1. The next state is even. That means the number of A's are even, and /0 means whenever I am in this state the output is 0. So this is clear. Next, we say from odd there will be two outgoing arrows. The first one is if the input is B, number of A's will not change. If my input is B, odd number of A's will remain odd. So I am transitioning back to the same state. And even if the number of A's are even and the input is B, we will transition back to the same state. So odd remains odd, even remains even if my input is B. If my input is A and the number of A's were odd, now they will become even. And similarly, if the number of A's were even and the input is A, it will become odd. So we are not counting, we are just indicating whether the number of A's are even or odd. And with this simple state diagram, we are able to design this system. So student, now we have a good idea about constructing a very simple system using finite state machine. Let us build something more complex, and we are going to design a 4-state counter using finite state machine in our next video. Keep learning. Thank you.